Databricks suggesting liquid clustering is a new concept, which you don't need to go for partitioning, which you don't need to apply G-order by also. While creating a table, like you don't need to specify partition by, even you don't need to go with optimize with the G-order by. So G-order by is optional. What you can do, we can go with clustering, liquid clustering. So how to use that? The cluster by. Hello everyone. In this video, I'm going to give you a brief introduction to what is liquid clustering and how it will give you a better performance when it comes to query related, and how to use that, and what are the major differences between the old approach and new approach. Okay, let's get started. I'm going to create a new notebook. So in this notebook, what we'll do, we'll use existing Databricks data sets. There you can find airline data. If you go to Databricks data sets, so there we can find airline data. So like a lot of files are available in this location. Let's attach the cluster. My cluster got terminated. Let's restart the cluster. The cluster is starting now. So what we'll do, we'll verify a difference between partition by and a G-order by, the old approach. The new option is clustered by. So how to use cluster by concept? What are the limitations on that? And what are the benefits we are going to get if you are using a cluster by? Nothing but liquid clustering concept. So optimize G-order. Optimize for reducing a small files issue. Let's see, if you have more number of small files, we can reduce that. Then another approach is partition by. So dividing data and split and store into multiple subfolders inside a table, that's called partitioning. So partitioning is optional now, because of partitioning and the G-order by, they are suggesting go for bigger tables, at least minimum 1 terabyte table. If you have a small table, still if you are using a partition by, how it will impact the performance, I'm going to show you with example. So now we can find a lot of data files, like 22 data files are available. I don't want all this data. Just I'll go with a single file, around a 700 MB file it is available. We'll take this data file. Say like data, I'll create a data frame. The CSV file, so spark.read.csv, which we can use the read API to read this data file, and header is available. So true, then info schema, true. Then I'll show you the data first. Then we'll create a partition table using a partition by. And then I'll show you that how many partitions created in this, like how many partitions are available in this data frame. Like you can use a function name called get num partitions. So if you run this query, it will give you how many partitions are available in this data frame. It's a single data file, so it will split and process. So when it is splitting based on the size, default, it will go with the 128 MB is the block size. Now it's less than 1 GB, so it is going with the 6 partitions. So what we'll do, the 6 partitions is going to create 6 files if we create directly one table. But if we create a partition table, so I'm going to create partition table. So format, I'm going to use a delta, then partition by. So meantime, I'll show you the data as well. I'll show you just some sample data. Show you 100 records. You see, I'm going to create a partitioning with any city or any other thing. Consider if you look at this, origin and destination. So what I'll do, I'll create origin basis partitioning. Okay. So let's create partition table, origin, then save as table. Just I'm giving a new table name, which is going to create a partitioning on origin with the entire this data. So 6 partitions are there. So the data frame level 6 partitions, then partition by column. So based on these values, consider origin is having some values, maybe 10 values are there. So 10 subfolders will create inside this folder. Then each subfolder again it will create a 6 files. So 10 into 6 it will create a 60 files. This is just less than 1 GB data. This is just less than 1 GB data. Then backend it is going to create multiple files. But blindly, we should not go with the police one because it is going to write a single file on each partition. Or you can say we can run optimize. So it will remove smaller files. Even we can run optimize, it can remove smaller files. Just I'm giving a why we should not use partition by georder by under smaller tables. Then after that, I'll give a same query. I'll create another table using a cluster by. So this is the table, right? Which we are going to. I'll show you the DDL. Show create table name. Then you can verify the job. So it is going to create a partition by an origin column, the backend. Even I'll show you how many files it will create. So default location for this is you can go and verify under user, under hive, under warehouse, then the table name. So here you can find this subfolders based on this origin. Based on this, is a column. Then consider if it is having a 200 values, 200 into 6 partitions. So those many files it will create in that table. So that's called small files issue. It's called small file issue. Actually, the file incoming file is just less than 1 GB. But backend, because of this partition by, it is creating a lot of files. Even that was small files. That too small files. So less than 1 MB data files. I'll show you. Let's wait a few more minutes. It will be done. So just we are trying to understand partition by, clustered by. Liquid clustering is a new concept. Let's take this DDL. What you need to do? Instead of partition by, just you can use a cluster by. Consider if you are going to use this column in a filter condition, then use the same column. Consider if you are going to use some other column. Consider if you are going to use other column for filtering or join, so then use that column. Consider what I'll do, I'll go for another column, day of the week. So I'll create a new table. So this liquid clustering option is available. While creating a table, you need to specify this option. So I'm creating a new table using a SQL clustered by day of the week. Okay. Now, so this clustered by how to decide and what's the limitations here when we are choosing a clustered by columns, right? If you are using a more in a filter condition, more in a group by, or you can say more in a join, right? So that columns you need to decide and use the clustered by. So that's why it will give you the better performance. Plus, maximum it will allow 4 columns. Minimum 1 column, 2 columns, 3 columns, like this. Maximum you can use comma separator 4 columns. So based on the priority. Okay. So this way, which we can go and create a clustered by instead of partition by. Then first we'll verify here. So you see the subpartitions it is created. When so inside this table, again folder name origin with the ABE, you see this. Again inside this you can find the 6 files. You see 6 files it is created. Why 6 files it is created? Because of data frame is having 6 partitions. 6 tasks are executed. At each partition it is created 6 files. So each partition this way. Partition by 6 files. How many partition values are there for the origin column? So 304 are there. So excluding that one, delta underscore log, 304 into 6, those many files it is created. Those many files, excluding this, so 304 partitions multiplied by 6, so those many files it is created. Then more than 1000 files, less than 1 GB, it is created more than 1500 files. Okay, when we are reading data, let's consider you're trying to read this data from this table and you are going to do some query. So I'm going to create a DFR table. Consider there's a column called day of the week. Day of week. It's not a day of the week. Just verify this. There's a column here, day of month, day of week. So first day of the week. Then it's the filter condition. I'm using this column basis, but the partition is created on origin column. And so I want to do the group by an origin and a month. Okay. Then I want to take a count. We'll create an alias name. So total number of flights. So this aggregation function I'm using, and then if you want to do that order by, so descending order. Top 10, okay, I want to take top 10. So top 10 means a limit at 10 you can use, limit 10 you can use. Okay, so by default, it will do this ascending order. So what we can do, we can specify ascending false, or we can use the call function, then we can specify DESC function. So multiple options. Okay, so limit 10. So let's use the display. Okay, so what I'm doing now, I'm trying to use one filter, two columns on group by, aggregate function, then order by, aggregation function and order by. So limit 10, top 10 records I'm going to take. Then we can use order by ascending or descending order, and then we need to import this function, count function. So how to import this? From PySpark.sql.functions import. Let's verify anything is invalid syntax. Okay, so count star, the function is available. The problem is it is not a SQL, it is a PySpark, right? It is specified inside a double quotes. Okay. So count, I imported this function, but the only problem was just I specified a star. So we need to specify a double quotes. Now we are getting the top 10 we are taking. Okay. It has taken 21 seconds. And we can go and verify how many files it is reading, this type of, because the backend files also available. So is it just less than 1 GB data? If you go to SQL data frame, we can verify the plan. Like just now we executed this query. So this is a total number of records. After filtering, you see this, after filtering, then after aggregation, finally we got a limit 10 records. Okay. But when we look at the backend files, how many files it is scanning? Number of files read 1699. Only 12 files it is pruning. But 1699 means 1700 files it is opening and it is reading. More this type of. Okay. So for smaller data, we have created more files. This is called small files issue. You can do the optimize georder by. Then it will reduce the files, but still, because of partition, minimum 300 files will be there. 300 files will be there. Even if you run optimize georder by, minimum it will have a 300 files. But if I go with this without partitioning, just a clustered by. Okay, just consider I'm using a day of the week. So filter I'm using there. So let's write data into this table. So instead of partition by, just I'll remove this partition by. So let's specify this table. So I'm writing directly data into clustered by table. Let's verify this table. Okay, we are using a save as table. That table is saying already exists. So we need to use the mode. So anyway, data is not available. I'll use append mode. Okay. If table is not available, if you're not specifying mode, it will go and create a table, but table already available. You should use the mode append mode or override mode. Just I specify the append mode. Now let's run the same query. Same query, instead of on partition table, just we'll go with the cluster table. This table. Even just we created we are creating directly this table, and even we can verify how many files it is going to create a backend, because it is not a partition table. So it won't create a subfolders inside that. Then how many partitions are there in the data frame? Those many tasks will be executed. So 6 files it is created. Just 6 files. Still, if you don't want 6 files, again, anyway, while writing, we can use the coalesce, reducing this. But just we'll go with the 6 files only. Just we'll go with 6 files. Now run this query. 2 seconds. This is 21 seconds. 2 seconds, 21 seconds. So the major problem, again, even we can reduce these files. After that, we can apply optimize and G-order by. Consider optimize partition table. So the G-order by on, consider day of the week column. I'm using a day of the week column. Then we can specify this. But if you are using the clustered by, you can avoid a partitioning concept. Even you can avoid this G-order by. Now, if you run this, what will happen? First, it will optimize. So each partition is having 6 files. So total 1700 change files are available. So it will keep 300 files. It will remove remaining files. So that's optimize. Again, when creating, based on this column, that when we talk about liquid clustering, similarly, the G-order by also is going to store a new data on this column specific. This column specific. So after that, we'll get a little performance, but still we'll have a more number of files. So what Databricks is suggesting, liquid clustering is a new concept, which you don't need to go for partitioning, which you don't need to apply G-order by also. While creating a table, like you don't need to specify partition by, even you don't need to go with optimize with the G-order by. So G-order by is optional. What you can do? We can go with clustering, liquid clustering. So how to use that? The cluster by. Even you can alter a table. Consider, I want to alter this table. The cluster by on 2 columns consider. I have to go with 2 columns. Consider month and origin. Okay, these 2 column spaces. Even we can go with month and origin basis. So alter table name clustered by optimize table without GR by, just optimize. Okay, so after changing the columns, what you can do, just you can run optimize, then it will change. So you don't need to apply GR by. Now, if you see this, we are applying GR by, it is going to take some time. You see. So it is going to remove all the small files. So instead of creating a partition table, instead of using optimize with the GR by, you can avoid this GR by, you can avoid a partition by, just go and use cluster by concept. This is called liquid clustering. Liquid clustering, which you can use for any type of table, even dimension tables or fact tables also you can use, SCD table, type 2 table, even if it is having huge data. Okay. Partitioning, they are suggesting you can choose partitioning at least minimum 1 TB data. The table is having minimum 1 TB data, then they're suggesting to go with the partitioning. Otherwise, liquid clustering is enough. So that's called cluster by is option, which is liquid cluster. So this way, which we can go and create a table. While creating a table, we need to choose the columns. Which column basis you want to do that. So now you say this 1700 files, it is removed. 300 files, it is 301 files, it is recreated. Now, if you go and run unpartitioned table, earlier it was taken 21 seconds. Let's go and run this. Instead of reading us 1600 files, it will read 300 files. But please, still 300 files are more files because clustered by just it's used 6 files. Now it is 300 files it is reading. So that's taken 2 minutes, 2 seconds, it's 5 seconds. Still we have a less data, but still you can see the difference. Use the cluster by for even smaller tables or bigger tables and run optimize. Run optimize. Even you can go through the standard documentation. Databricks liquid clustering. Okay, so liquid clustering is available from Databricks runtime 13.3. So when we are creating a cluster, you can find a cluster runtime Databricks runtime. Here you can see this. So LTS version and even 14.0 is available. Even upcoming version 14.1 beta version. So it is available from 13.3. Okay. So GRW columns, nothing but liquid clustering columns. That's all. But maximum 4 columns which you can specify here, which you don't need to go with the GRW. Okay. So Databricks recommended choosing cluster key columns based on commonly used for filters, grouping, joining. So those columns is better. First the priority is the joins because the pruning will happen based on that. Even when we are using a filter, static pruning will happen. Whenever you use the joins, the dynamic pruning will happen. So for pruning point of view also, the best you need to select that cluster key columns, maybe 1 column, 2 columns. And this table, you see this day of the week, right? So now if you want to disable this, even we can disable this. Okay, or you want to alter that again. Whenever you alter, right? Consider I want to alter with 2 more columns. So after altering, you need to do optimize. So you can run optimize. Once you optimize, then it will impact for new columns. That liquid clustering will impact for new columns. So this way, which we can go and create clustered by table, nothing but liquid clustering concept. So now you can avoid a GRW, you can avoid a partitioning, then just to decide which columns. And the limitations are here. Only you can use of maximum 4 columns when they already mentioned in the documentation. You say the structured streaming workloads not support clustering on write. Okay. And maximum 4 columns. Even after creating a clustering, even you can go with the describe detail. It will give you that information. Describe detail and this table. So again, whenever you run optimize, right, again it will remove the small files. Always remember this. Now this table is having 6 files. It will get average file size 1 GB files. We don't have a 1 GB data, so 1 file it will create. So out of 6 files, it will remove 6 files. It will create 1 file. You say the 6 files it is removed. It's created in 1 file. Then you need to use the vacuum. So vacuum to remove this deleted files because by default delta will have a time travel. So you can just vacuum retain 0 hours. This time removing so we need to disable this. By default, this retention duration check will be enabled. 7 days retention duration check is enabled. We can disable this. Then we can vacuum. Because I'm just going for 0 hours because just now we deleted those files. Just I want to show you that once you clear those files, then only 1 file you can find in this location out of 6 files. This table, where it is here. So now we want to verify this liquid clustering table. Only 1 file. Even we deleted those files. After that, even we vacuum. So we purge those files. So now if you run the query, only 1 data file it is available. This partition table, cluster table. So earlier it's taken 2.7 seconds. Now we have only 1 file, 1.9 seconds. Instead of reading 6 files, it is reading only 1 file. So optimize you can run. If you want to change that clustered columns, even you can go and change the cluster columns. Then after change the cluster columns, you need to run optimize. So remember that when you are running optimize, so no need to specify GRW. Then even you can describe detail. If you go and verify the backend, you can see this clustered columns, month and origin, these 2 columns. How many data files? 1 data file. Size of the size in bytes. So So this way, which we can enable liquid clustering, we can avoid partitioning, we can avoid reorder by just optimize liquid clustering. These two combination, we can achieve better performance. Still, you can go with the partitioning, but that is not suggested for smaller tables. Go for at least minimum 1 terabyte table. Then you'll get a better performance. Otherwise, liquid clustering is enough for that. Thank you. Thank you for watching my videos. See you in another video. Have a good day.